This is solutions to your practice tests that was posted last week. So question 1 here, it has us match an equation with a graph. So this is y equals 2 to the x negated. So remember, anything that's like b to the x, if b is greater than 1, has this look to it, okay, when it crosses the y-axis, okay, but when we negate it, it's going to flip it over the x-axis. Alright, so which one of these looks like this thing flipped over the x-axis? This one. Okay, none of the other ones look that way. So our answer here is A. Okay, now another way that we could know that this is right is to throw that thing in our calculator. Zoom 6. Alright, or you could make your window -5 to 5, -5 to 5. But anyway, there's that look again. Alright, let us know that it is A. Alright, for question 2, 3, 4, 5, I may not give you these as multiple choice questions when it comes test time, but anyway, the same idea applies to what you're doing here. So here I'm given a function. This is an exponent. This in the parentheses is an exponent. So I want to find out what happens when 4 goes in. So just literally take that x and replace it with 4. So 3 to the 1 minus 4 equals 3 to the -3. Okay, now this is not multiplication, so it's not 9. Okay, it's 1 over 3 to the +3, which is 1 over 27. Okay, and that's answer B. Again, use your calculator to help you. Alright, so this is 3 raised to the parentheses 1 minus 4. Alright, hit enter, and then after you do that, hit math 1 to change it to a fraction. Alright, and then there's your answer. Alright, we're going to do the exact same thing we just did, except this time we're going to get a decimal and round it. So plug in, this is 2.8. E to a power is this second key of the LN button. So 2.8 e to the -2.3 times x, and they want us to use 0.8 for x. Alright, close that parentheses. So there's what we get, 0.44468, which is C. Alright, what's the domain and range for that equation? Alright, I can put anything in there, okay? I can put anything into this function as an exponent. So 2 to any power exists. So that means it's going to be -infinity to +infinity. So we've eliminated D. Okay, but the range, 2 to the x is always positive. If I go into my calculator, alright, I've got -2 to the x stored in there from the first problem. Delete that negative. And notice this graph is always positive. It's never negative anywhere. So that means our range is from 0 to infinity. Okay, anything that has negatives, alright, or 0 is not part of it. So our only choice here that has both is C. Alright, 5. Write the log equation in exponential form. The easy thing to do here is to take your base, this is the base of the logarithm, go across the equals, that's going to be your exponent. Alright, and then go back across the equals, that's what it's equal to. So we end up with W to the 5th is equal to Q, right, which is C. Alright, we'll write this in a log form. To write a log form, what you have to remember is a logarithm is an exponent. Alright, so is the same thing as equals. So the log base, what's the base? The base is 8. It's what's being raised to a power. So the log base 8 of something equals something. Okay? But the log over here on one side of is where our equals is going to be. Alright, is another way to say equals. Okay, 2 plus 2 is 4, 2 plus 2 equals 4. The log equals the exponent. Okay, what's the exponent? The exponent was 3x. So that means it's going to be over here where exponent was. Alright, and what does that leave? That leaves that leaves y. So y is the only thing that hadn't been accounted for. Okay, now what you can check yourself is just what we did on the last problem. 8 to the 3x equals y. 8 to the 3x equals y. Alright, but this is the kind of the key to doing the transformation either way. Understanding that a logarithm is an exponent. Is means equals, so that means log, the log stuff is on one side of the equals. What's on the other side? The exponent. So this 3x is isolated on one side, and then the log stuff is on the other. Just remember, this is a base in exponential form. This is where the base goes in the log form. Okay, so which one is that? Log base 8 of y equals 3x. That's B. Alright, find the value of the logarithm without using a calculator. Remember, log, or ln is the log base e. Alright, and then this is e to the 4th. And then anytime that you have the same base of the log and the exponential, they wipe each other out, and your exponent just falls down. So our answer is A. Alright, find the inverse of the function. Okay. Remember the steps to find an inverse. That was on your last test. I gave you those steps. Replace y with, or f of x with y. Alright, and then interchange x and y. X equals e to the 7y, and then solve for the new y. So we need natural logs. So natural log of x equals natural log e to the 7y. Alright, same thing that just happened in the last problem. The ln and the e wipe each other out and just leaves the exponent. So this ln and this e are going to wipe each other out and just leave the exponent. So we end up with the natural log of x is equal to 7y. Alright, then divide away the 7. Alright, and we get, this is our inverse function. So f inverse x equals natural log of x over 7. Alright, natural log of x over 7, same thing as this. Alright, the natural log is out to the side. Alright, we moved over here and just replaced it with a 1, so same thing. Alright, 9. Rewrite as a single logarithm. Combine this thing down. So the first thing we're going to do is the power rule, meaning we're going to take these numbers out front and put them on the parentheses. So that 3 is going to come up here. That 2 is going to come up here. Alright, and we have the log base 6 of 5x minus 1 cubed plus log base 6 of 2x plus 8 squared. Alright, and then we're going to use the product rule, meaning we're going to replace this plus with multiplication and wipe out a log. So it's basically going to look something like this. This minus goes away, or sorry, this plus goes away, becomes a times dot, and we don't need both logs, so we're going to get rid of that, and then these two things are going to come together. So we end up with the log base 6 of this 5x minus 1 cubed times 2x plus 8 squared. Alright, all in the input of that logarithm. Okay, so that is going to be B. Alright, 10. Animal species introduced in a certain area. The population is approximated by this function. T represents the number of months since its introduction. Find the population of this species 6 months after its introduction to the area. Round your answer to the nearest whole number. Alright, so this is just plugging in a number into a function. Alright, that's what you got to understand. That's all you're being asked to do here. So turn it on first. 400 times the log of 2t plus 3, but we're going to put in 2 times, instead of t, we're going to use 6, because t represents how many months, and it's 6 months plus 3. Alright, close parentheses, enter. 470.4. Alright, to the nearest whole number would be good old 470. Alright, 11. Find the exact answer, then round it to 3 decimal places. Alright, so here, you can do it either way. You can bring in the natural log, or you can bring in a common log, it doesn't matter. But just bring in a log. I'm going to bring in a just regular log. 4x equals, but make sure you do it on both sides. Alright, so these things were equal to begin with, so that means their outputs in a logarithm would be equal. Now, the reason why we do that is it allows us to bring a property of logarithms, allows us to bring the exponent down in front of the log. So we're going to put that x right there. And now we've got the equation x times the log of 4 is equal to the log of 11. Right? The log of 4 is just a number, so I can divide it away on both sides. Alright, and I get the exact solution that x is equal to the log base 11 divided by the log of 4. Now this is not equal to the log of 7, or don't misuse the quotient rule. This is your exact answer, and then go to your calculator to approximate it. Alright, and then type in exactly what you saw there. Log of 11 divided by the log of 4. Alright, and we get 1.729. They want 3 decimal places, so 1.730. Alright, 12 wants us to use the change of base property to approximate this thing. So change of base, according to the change of base property, I can say that this is the natural log of 0.556 divided by the natural log of 6. Right? The natural log of the original input divided by 556 divided by the natural log of the original base. Alright, into 3 decimal places, that's approximately natural log 0.556 divided by natural log of 6. Oops, had a wrong button up here. That's better. Alright, hit enter. Negative 0.3276. So there's our answer. 3 decimal places. Alright, now notice too, also this goes back to the last problem too. I could have just as easily replaced natural log with log in both places. Alright, if I wanted to use log instead of natural log. Alright, I get the exact same thing. Just make sure not to mix and match. Don't use ln for one and log for the other. Alright, 13. Solve the equation, give an exact solution. So in this problem, I've got 2 logs on the left, 1 log on the right. So what I want to do is condense this side down to a single log, alright, and then drop the logs. So I get the natural log of x divided by x minus 6 using the quotient rule. Our quotient property is equal to the natural log of 7. Now this kind of uses the same logic as a couple problems ago when we had basically what's inside of these logs and then we brought in the logs. Same idea. If it's the same logs on both sides and they're equal, then it's the inputs that are equal. So x over x minus 6 is equal to 7. So that's the equation that we end up needing to solve. Alright, multiply both sides by x minus 6 and we get x equals 7 times x minus 6. Okay, just multiplying both sides by this to clear the denominator. Distribute this 7 through and I get x equals 7x minus 42. Alright, I'm going to move this 42 over to the other side, and at the same time I'm going to subtract this x away from both sides. Kind of cut to the chase a little bit. So there's going to be a 42 over here. On this side there's going to be a 7x minus x, that's a 6x. Divide away the 6 and I get x equals 7. Now anytime you have a log equation, you need to go back and check your your solution in the original problem. So we got 7 as our solution. So everywhere there's an x over here, I'm going to plug in 7 to see if it works. Natural log of 7 minus natural log of x minus 6, we're saying that's 7 minus 6. Is that equal to the natural log of 7? Well, type in natural log of 7. Are they the same? Yes. So that means that our answer is 7. Okay, now you have to check because it could be that it doesn't equal and then you'd have no solution. So make sure you check. Alright, explain the error, if any at all, in this following process. The error is when you combine this to a single log like they did, it's the 2 and the m get multiplied together, not added. So they added when condensing. Which should be multiplication. So we should end up with a log base 3 of 2 times m instead of 2 plus m. Alright, so this problem, find the exponential function that satisfies the given conditions. Initial mass is 20 grams, so that means we should start off with 20. Alright, so that one's out. Starting off with 20, and it decreases at a rate of 0.36 per day. Alright, decreases at 0.36 per day. So 3.6% is the same thing as 0.036 as a decimal. So we need to multiply by 1 minus 0.036, okay, which is going to be 0.964. Alright, so that's going to be A. Alright, this is increasing at 3.6% per day. Alright, so make sure that you get that correct. And then this is just they didn't do their decimal right. And it's increasing as well. So decreasing, we subtract the decimal version of the percent from 1, and multiply 20 by that to the t power. Alright, find the amount of money in the account after 5 years if this much is deposited at 5% interest compounded monthly. So our compound interest formula is the amount in the account is equal to P times 1 plus R over N to the N times T power. Alright, P is your original principal, so that's 1400 times 1 plus R is the rate written as a decimal, so 0.05 over N is the compound periods in a year, so monthly means that N is 12. So that's 12. This is N, so this is also a 12. Times T is the number of years, so 5 years. That means T is 5. Alright, and then plug that into your calculator. Now, when you get to the exponent, do one of two things. Put parentheses around the multiplication, or your other option is to multiply that out in your head or multiply it out ahead of time and say, alright, this is 60. Alright, but what you don't do is leave those parentheses off of there and still write it as multiplication. If that's what you end up doing, then you get something way, way, way off. Okay, so 1796.70, which is D. Alright, what will be the amount in the account with initial principal of 5,000 if interest compounded continuously? So continuous compounding, we use A equals P times E to the RT. Alright, so this time P is 5,000 times E to the R is still the rate written as a decimal, so 0.0425. Alright, and then T is 8 years, so that times 8. Alright, so again, go to your calculator, plug it in exactly how you see it. 5,000 E to the power is second ln 0.0425 times 8. Alright, close that parentheses after you put everything in there. So we get 7,024.74, which is B.